Hello, welcome back to AC circuit analysis. We're going to solve this problem. Here we have some box, we're calling it A, and some box, we're calling it B. We have wires connecting these boxes. We know the current going this direction, we're labeling it I, and we know the voltage drop across these terminals, plus minus, we're calling it V. Now we're going to give several different cases, but the first one is we're given V and I by these cosines here, and what we really want to do is calculate the real and reactive power. So when you see that, you want to calculate P and Q. P is the real, average real power, and Q is the reactive power. And then we want to kind of interpret the results. Is power quote-unquote flowing from A to B this direction, or is it going the other way from B to A? So we'll have several different cases here, and from that I think you'll learn a few things. So in order to calculate the real power, we go back to that equation we've used, capital P, and it's Vm Im over 2 times the cosine of that phase angle, theta V minus theta I. All right? And so basically we want to perform that calculation. So what we're going to do is Vm, for this case, Vm, the amplitude of the voltage here is 250, and for the current is 12. So it's just going to simply be 250 times 12 divided by 2, and then we'll have this cosine of this phase angle. Now the phase angle for the voltage is positive 45, the phase angle for the current is negative 15, so you'll have 45 minus a negative 15, which will end up becoming a positive here in just a second. So what we're going to have is capital P is going to be, when you take 250 times 12 divided by 2, what you're going to get is 1500 times the cosine, and inside of these parentheses, 45 minus a negative 15 would be positive 60 degrees. And when you do that math, 1500 times the cosine of 60 degrees, you'll get 750. And the units of real power is just the familiar watts. Okay, now the question is, we want to, first of all, kind of figure out what this was really telling us. Notice how we have things drawn here. The voltage drop is oriented plus to minus, and the current is going down in that direction. So it's written in the common direction as if this were like a passive load, like a resistor, and the voltage is going through a voltage drop. So if we get a positive number for the power, for the real power, it's going to be absorbing energy like a resistor would. And if we get some negative answer, then that means whatever's in here is not a resistor, and it's delivering energy, delivering power out. So in this case, we got a positive answer. So this B quantity must be absorbing energy. And because you have to have conservation of energy, that means the energy must be coming from some source going from A to B. So the way we'll kind of write that is it's going from A to B. So for every problem, we're going to kind of write down what it means. Is it absorbing or delivering? And then we're going to try to figure out if it's coming from A to B. So this is the answer for the real power of this guy here. And then now what we want to do is go and calculate what the reactive power is doing. So the reactive power, the equation for this guy is going to be Q. It's going to be very similar. Vm times Im over 2, but you'll just have the sign of theta V minus theta I. So it's almost exactly the same thing. And you'll get all the same stuff here. So what you're going to have is 250 times 12 over 2, the sine of 45 minus a negative 15. Everything's the same except it's a sine, and so you'll have 1500 times the sine of 60 degrees. And so then Q, when you take 1500 times the sine of 60 degrees, you will get 1299.04. We could round here if you want. The unit of this is not watts. Well, it is the same.